Object recognition. In this lecture, we'll see what is object recognition, system components, the complexities in object recognition, and knowledge representation. An object recognition system finds object in the real world from an image of the world using object models which are known a priori. The task is surprisingly difficult, but human brain can do this job within a second and effortlessly. Depend on experience, what he has or what he learned throughout their life. The object recognition problem can be defined as labeling problem based on models of known objects. Given an image containing one or more objects of interest with the background and a set of labels corresponding to a set of model known to the system. The system should assign a correct label to a region in the image. Now we can see here one image in which different objects are present. Circular object, square object and triangular object is present with the background, but we are interested in a smaller square. Now let us see the components of system. There are four components. An object recognition system must have the four components to perform the task, and these are model database, also called as model base. Second is a feature vector. Third is hypothesizer, and the fourth one is hypothesis verifier. A block diagram showing interaction and information flow among different components of the system. The model database contains all the model known to the system. Now let us consider here we have three types of object: triangular object, circular object and square object. The database of these three objects is stored in the database. The information in the model database depends on approach used for the recognition. It can vary from qualitative or functional description to geometric surface information. In many cases, the models of objects are abstract feature vectors. A feature is some attributes of the object that is considered important in describing and recognizing the object. Here we have three objects: circle, circular, square and triangular. So we need to find some feature from this object which recognize exactly that this is a triangle, this is a square and this is a circle. So we can find out the feature based on size, color and shape. So here in this case we can use size and shape. These two attributes we can use and we find out what color of what exactly present in the image. Either it is a triangle, square or circular object. The feature detector applies operators to images and identifies location of features. That help in forming object hypothesis. The features used by a system depending on the type of object to be recognized and organization of the model database. Now here in this case we have to find out the shape of the object. Our problem definition is to find a square object, so better we use a shape or the size of the object. There is no use of color in this case. So depending on problem statement, if I want to verify which kind of a fruit is present in the given image, then at that time I can say that if it is circular shape and red color, then it is cherry. So depending on problem, we can change our feature, which kind of feature we want to use or which type of database I want to create, that I can change. So it is depend on the type of object to be recognized and the organization of the model database. Using the detector features in the image, the hypothesizer assign likelihood to the object present in the scene. This step is used to reduce the search space for the recognizer using certain features. The model base is organized using some type of indexing scheme to elimination of unlikely object candidates from the possible consideration. Now here the indexing is given as, I have given one example. Now for triangular, what is for triangular shape, what is the area, what is perimeter, what is the chain code of a triangle, what is the compactness of a triangle, what is the signature of triangle. These kind of features I can calculate. Similarly for the other object like circular object and square object, this kind of features I can calculate for each and every object, and I can create my database, and that is nothing but what the indexing. The system then selects the object with the highest likelihood based on all evidence as the correct object. And I'm for testing data, for testing input image, I will find out all these features: area, perimeter, chain code, compactness and signature for testing image, and I am matching with the database given or what we have, and which is the nearest, which is for particular object, which one is the nearest, that I can say that according to that I can say that it is a triangular object, circular object or a square object. The hypothesis formation and the verification components vary in their importance in different approaches. Some systems use only hypothesis formation and then select an object with the highest likelihood as the correct object. This is very important. In the classical way, we can say that it is there are four types of system components, but in pattern recognition or pattern classification, artificial intelligence, it just relay little on the hypothesis formation and do not work in the verification and do more work in the verification phases. Now let us see some issues, the central issues that should be considered in designing an object recognition systems. There are 5 issues. First is object or model representation. Second is feature extraction. Either it is a local feature or global feature. Third is feature modeling matching. Fourth is hypothesis formation. And fifth one is object verification. Now, first is object or model representation. How should object be represented in the model database? What are the important attributes or the features of object that must be captured in this model database? That is comes under object or model representation. For some objects, geometric description may be available, may also may also be efficient, while for another class one may have a rely on geometric and functional features. The representation of an object should capture all relevant information without any redundancies and should organize this information in the form of easy access. Second, feature extraction. Which features should be detected and how can they be detected reliably? Most features can be computed in two-dimensional images, but they are related to three-dimensional characteristic of object. Due to the nature of image formation process, some features easy to compute reliably while others are very difficult. Now let us see what are two types of feature. Global features. Global features usually are some characteristics of a regions in image such as area, size, perimeter, Fourier descriptors and movement. Global features can be obtained either for a region by considering all points within a region or only for the boundary region. We have already covered all these methods how to find global features. Now, what is local features? Local features are usually on the boundary of an object or represent a distinguishable small area of a region. Curvature and related properties are commonly used as a local feature. High curvature points are commonly called corners. Local features can contain a specific shape of a small boundary segment or a surface patch. Some commonly used local features are curvature, boundary segments, and corners. Third is feature model matching. How can feature and image be matched to model in the database? In most object recognition tasks, there are many features and numerous objects. Some matching approach will solve the recognition problem, but may they are too slow to be usefulness. Effectiveness of features and efficiency of a matching technique must be considered in developing a matching approach. Fourth is hypothesis formation. How can a set likely object based on the feature matching be selected? And how can probabilities be assigned to each object? The hypothesis formation step is basically to reduce the size of search space. This measures reflects the likelihood of the presence of objects based on detected features. And the fifth one is object verification. How can object model be used to select the most likely object from the set of probable object in a given image? If the models are geometric, it is easy to precisely verify object using camera location and other scene parameters. So depending on the complexity of the problem, one or more modules as shown in figure. For example, pattern recognition based object recognition system do not use any feature model matching or object verification. They directly assign the probabilities to the object and select the object with the highest probability. Now let us see what are the complexities of object recognition or challenges. Images of scenes depend on illumination, camera parameters and camera location. The complexity of object recognition depends on several factors. Object recognition task would consider the following factors. First one is constancy. The scene complexity will depend on whether the images are acquired in similar condition, what is the illumination, what what the things are present in the background, camera parameters and viewpoint. How many pixel of megapixel camera is used, what is the light condition, the things which are present in the background, all these matters or all this comes under scene complexity. Under different scene condition, the performance of different feature detectors will be significantly different. The nature of background and other objects illumination must be considered to determine the kind of feature can be efficiently and reliably detected. Let us take one example. Suppose if we are finding out the feature based on the color, then if we are interested in one object and that object color is red, and suppose the same color, red color, is present in the background, so it is very difficult to find out or segment out that red object from the background. So this kind of complexities or are coming into the picture. Now in that case, only the color feature is not sufficient to find out a particular object from the image. We need to use some more feature which are related to shape, size or the texture, or which are based on the other attributes. Second complexity is image model spaces. In some application, images may be obtained such that three-dimensional objects can be considered as two-dimensional. The models in such cases can be represented using two-dimensional characteristics. If models are three-dimensional and perspective effects cannot be ignored, then the situation becomes more complex. Thus, the same three-dimensional features may appear as a different features in an image. This may also happen in dynamic images due to motion of the objects. Now there are two types of images are present. One is a static and another one is a dynamic image. Now if a still image is there, a single frame is present in the image, we can say that it's a static image. And if we are using a video, then it is called as a dynamic. Now if we are using a video or a dynamic database or a dynamic video, in that case we need to consider a three-dimensional object. If it is a static, then we can consider a two-dimensional. So this kind of complexity are coming into the picture at image model spaces. Third is number of objects in the model database. If the number of object is very small, one may not need to hypothesis formation stage. A sequential matching may be acceptable. Hypothesis formation becomes important for a large number of objects. The amount of effort spent in selecting appropriate feature for object recognition also increases rapidly with the increase in the number of objects. So it is very easy if we are interested to find a one object, and if only one or two objects are present in the image, it is very easy to find out that particular object. But if number of objects are present in the particular image, then the task is difficult. So the complexity is increases as the number of objects are maximum. The next complexity is the number of objects in an image and possibility of occlusion. If there is only one object in the image, it may be completely visible. With an increase the number of objects in the image, the probability of occlusion is increases. Occlusion is a serious problem in many basis images. Now here one example is given. If we are interested to find the square type of object and circular object is already present in front of that square, so part of square is visible but other part is not visible, and that is called as a occlusion effect. Occlusion result in absence of expanded features and the generation of unexpected features. So if we'll find out the features of given square from the image, we are getting something different features from this. So this is one main problem of occlusion in object recognition. Recognition strategies. Object recognition is a sequence of steps that must be performed after appropriate features have been detected. Not all object recognition techniques require strong hypothesis and verification steps. Most recognition strategies have evolved to combine these two steps in varying moments. As we see in the diagram, only the hypothesizer or the classifier is used and the features are given to that hypothesizer, and directly the output is particular object. Similarly, in other diagram, features are given directly to the verifier and we can recognize a particular object. One may use a three different possible combination of these two steps. Or the third possibility is we can use both the hypothesizer and a verifier, in which the features are given to the hypothesizer and the output is given to the verifier, then object can recognize. Depending on the complexity of the problem, recognition strategies need to use either or both the hypothesis formation and verification steps. Next topic is knowledge representation. Knowledge representation, it is a set of syntactic and semantic conventions to describe a piece of a knowledge. In order to build knowledge bases, experts describe the content of their knowledge using knowledge representation schemes. Now in the diagram, one decision maker whose actions are justified by a sensing the environment using knowledge, but if we remove the knowledge part, we will not be able to display any intelligence. Let us take example. For a toddler, if we ask to recognize a particular alphabet, he is not able to recognize a particular alphabet because he don't have that kind of a knowledge. He don't know what are the alphabets. So knowledge is very important, and the same thing if I'll ask to a boy of 5 years, he can easily recognize based on his knowledge this is which type of alphabet. This is what the relation between knowledge and intelligence. Without knowledge, if I'll remove this knowledge from this diagram, there is no decision making or there is no intelligence. So intelligence is depend on the knowledge. Now let us see what are the knowledge representation techniques we are using. There are four types of techniques. First is logical representation. Second is semantic network representation. Third is a frame representation. Fourth is production rules. Let us see one by one with the example. Logical representation. It is a language with some defined rule which lead with the proposition and has no ambiguity in the representation. It represents a conclusion based on various conditions and lays down some important communication rule. Each sentence translated into logics into a syntax and semantics. Simply we can say that syntax is nothing but grammatical way to represent, and semantic is what? The meaning. Syntax is how we can construct a legal sentence in logical manner. It determines which symbol we can use in representation and also how to write a particular symbol. Semantic are the rules by which we can interpret the sentence in logical way. It assigns meaning to each sentence. Then second one is semantic network. Now semantic network, in this we can define this in the form of object attributes and value. A particular object I can define to a value depending on attribute. Now let us take example of mango. Here the object is mango and attribute I am using taste. Which kind of taste mango has? If I am saying the mango is a sweet, so value is sweet. Object is mango, attribute is taste, and the value is sweet. Similarly, if I am using a different attribute, the object is same mango, but if I am using a category attribute, then which kind of category it comes under? Mango comes under, it's a fruit. That's why the value is fruits. So depending on this attributes and object, we can find out a different values. Here in this case, we can say that depending on taste, shape and color, we can define it as mango, or it is apple, or grapes. Or if I'll take another example as Google database. Google is one of the example of information. When we search for particular topic, then it shows information. So it is related to save the information based on knowledge in meaningful graph. The definition of semantic network work as an alternative of predicate logic for knowledge representation. You represent your logic is in the form of graphical network. These network consist of node representing object and arcs which describe the relationship between the objects. The advantage of this kind of representation is these networks are simple and easy to understand. But the disadvantage is it takes more computational time at runtime. Next is production rule. In production rule, agent checks for the condition, and if the condition is exists, then production rule fires and corresponding action is carried out. Now here some examples are given based on production rule. If I am using here if, and, or, and, then. In this case we are using if, then condition, and or then another condition, then conclusion. If this and this has happened, then only the conclusion I can conclude. Let us take example for this. If if I'm using the example of, if I'm taking the example of fruit, which kind of fruit is present, I can write if color is a red and shape is a circle, then I can say that this fruit is a cherry. Another kind of rule is given. If room temperature is less than 19, then I want to switch on the cooler. Then change the heating status to on. Fourth representation is frame representation. A frame is record like a structure that consists of a collection of attributes and values to describe an entity in the world. These are data structures that divides the knowledge into substructures. It consists of a collection of slots and slot values of any type and size. Slot have names and values are called facets. This frame representation is just like a semantic network, but in this fixed format or a data structure is defined in which we store our data. Let us take example of a railway ticket. A fixed frame or the format of railway ticket is fixed, and we are entering the data like the name of person, age of person, destination, etc. So this is one example for frame representation. Frames are already available and we have to enter the data into a frame. The advantage of this kind of representation is it is easy to understand and visualize. Very easy to add the slots in this, but the disadvantage is it is very generalized approach. Thank you.